We're just going to get started right now. I just want to briefly introduce ourselves. We are students here at the college. We're part of the ECE department. All of us here are computer engineers. And our senior project is the Bluetooth wireless audio relay. I'm Dennis Donnelly.
I'm Mike.
I'm Jeff. I'm Kevin.
And then our advisor is Dr. Anthony Deese. Some of you may be.
So the goal of our project is to create a Bluetooth wireless audio relay, or a device that captures and sends audio wirelessly. We want this device to be commercially viable, so there are a few requirements we have to meet. The first one is the cost. We want it to be $10 or less. For the size, we want it to be 45 by 30 by 10.7 millimeters. And the bitrate has to be MP3 audio quality. All these requirements need to be hit in order to make it a commercially viable product. We're also putting a heavy emphasis on the documentation in order to create a solid tutorial for future teams that will eventually take over our project. They can easily see what we've done so far and quickly move on to implementing new features.
All right, so here's some of the software and the hardware that we've been using to develop our product. So we've been using NRF Connect, Visual Studios for coding, Sega Embedded Studios, and Android Studios to develop the Android app. And in the hardware we've been using two dev boards. We've been using the NRF53, which is, we'll get into those later, the differences, and the NRF52. The 53 is just full power Bluetooth, and the 52 is Bluetooth low energy. The 53 has more capabilities than the 52. We'll get into why we use both of them later. We're also using a Galaxy A20, which is the Android phone we're going to be flashing our program onto, the Android Studios program. And then we're using the I2S Adafruit microphone, which is what we're going to be using to capture audio.
So design challenges that we have run into, I know with board development and looking at the NRF53, which is a primary board that we'll be using, we ran into issues flashing on the device where we had to disable some of the device protections that were on it. And the documentation on it was very minimal to start. I had to start looking into both the Dev Zone and the Dev Academy, which I didn't know existed until I dug a little deeper into Nordic Semiconductors. And then when you're building, you have to make sure that you have the proper environment and using the proper setup for the config files. Otherwise, you won't be able to build, and therefore you won't be able to flash your application onto your board. And then the SDK, the software development kits, rapidly update. A lot of the documentation is on SDK 1.7.1 for most NRF52 applications, because that's the most popular Nordic Semiconductor microcontroller. And when it goes into higher SDKs such as 2.5.0, the Zephyr RTOS modules are deprecated.
Then for the app development, which is the software app that comes in tandem with the dev boards, that there's a way for them to communicate wirelessly. One of the biggest issues that we ran into was permission enabling. So what this basically is, when you, let's say you open a new social media app and you want to take a picture, you look at a prompt that asks for permission to use your camera. And this is set up to protect users and give them more privacy. However, when you're coding this, it can be very easy to either accidentally enable a permission you're not supposed to, or for it to not even work if you enable it. For example, when I was programming the app, I wanted to have a permission set up for the microphone, to use the microphone of the Android device just to test out the audio. However, if I hit yes, it wouldn't enable the microphone. This is an issue that ran over the course of weeks to kind of figure out what the issue was. And this was because of the second issue here, which was the frequent updates. Frequent updates might be nice on surface level. However, when you're developing an app, it can sometimes override code you already wrote, or you're using a library that no longer exists or it got deprecated. So what the result was that I needed to add an extra line of code in a very small file that was very varied across all the other Android files and OS. And that resulted in me not being able to set the microphone. So this one small little line of code set us back a weeks. So it was very important that we had to put that in documentation for future use.
So this is going a little more into the firmware development. So the primary application you'll be using is the NRF Connect for desktop, which will pretty much shoot you over to Visual Studio's code. As there's an extension that they have called the NRF Connect for VS Code, I'm pretty sure. And then it's just a package that allows you to flash and debug all sorts of Nordic devices. So on the NRF Connect for desktop, you have your toolchain manager that allows you to download the newest SDKs. It also has different modules that you can download, such as the Bluetooth Low Energy package, so that you can look for any advertising Nordic devices to be able to connect to them. And then there's also the programmer, which allows you to interface with the memory on the board to be able to erase it and then also flash program data. So that's an optional IDE that you can use rather than just using Visual Studio's code. For Visual Studio's code, it's a recommended IDE. And to get started in the toolchain manager, it will want you to download the newest SDK and then prompts you to open up Visual Studios and then download the proper extensions. So with the board, this is just going into what's innate with it. So there's a Zephyr RTOS and an onboard J-Link. So the Zephyr RTOS is a real-time operating system. It's used on most boards. It's most notably aligned with SDKs of 2.0.0 plus. So it supports more kernel usage than previous development boards. So that's why a lot of the changes from SDK 1.7.1, it was deprecated. So the main purpose of the Zephyr module is to streamline the standard usage of libraries and interfacing of board components, such as if you wanted to use any buttons or LEDs on the development board. This supports a more streamlined application into getting into it. The Zephyr RTOS also has a scheduler in it. This will allow you to make any programs that you flash onto the board able to do multiprocessing or multi-threading. So onto the onboard J-Link. This just allows any board from NRF 52 or higher, including the NRF 53, to turn the entire board into a full evaluation kit. It allows you to debug your program without the use of an external OEM purchased probe. And it also provides faster communication between the target CPU and the IDE without adding a significant cost.
I'll talk about the IDE we use for software component with the Android application. So we use the Android Studio, and this might seem kind of obvious to use. However, there are very blunt trade-offs with different IDEs. For example, VS Code, in my opinion, is a little bit easier to use, a little easier to manage. However, for our purposes, Android Studio would be pretty beneficial. And here's some of the reasons why. For example, we have to make one of the goals of our projects, make it user-friendly and be able to eventually turn into a product. So this meant that we would have to have a very streamlined user interface. So this is very helpful with Android Studio because they would give you a sort of side panel of what the screen looks like in real time. So as you code, it'll update the UI on your screen. So you can very easily see where your buttons are going, what the button looks like. You can see the different images you put on the app. So it's very easy to see what I was programming. Another reason why we used it was for the advanced emulator that it has. Being an Android or being an IDE designed for Android applications, they allow you to have an emulator of an Android phone. So what this basically means is that you can have a digital phone and you can test your application using that instead of having to constantly update the app on a physical phone. So that saves us a lot of time with testing and changing the code. And then also the seamless integration, which deals with having a lot of libraries available using Android. And we'd have a lot better access to the operating system to, like I said earlier, manage the permissions. However, there also are some drawbacks to using this. For example, there's a very steep learning curve, at least in my experience. I've never used Android Studio before. And learning all the different files, configurations within Android Studio is very complicated. There's probably hundreds of files that all do like a small task within like an emulator, for example, and finding out and debugging what is going wrong can be very complicated and time consuming. Another thing would be the Gradle build times. The Gradle is what runs the emulator, and it could take upwards of a minute to even start it up. So if I change one line of code and I want to test out what this line of code did, I'd have to wait like a minute just for the emulator to pop up. And this can be very annoying during development. Like if I'm on a roll and I'm really starting to get ideas flowing, it can really slow that down and it makes it difficult to sort of develop for long periods of time. And also, like I said earlier, the frequent updates, they introduce lots of new features. However, they also get rid of a lot of old features. And a really big issue with this was that a lot of libraries that'd be very useful for us. For example, One was the streaming or audio streaming library. This became deprecated in API 31, and I'm using API 32. So I'm one API level in front of it, and no longer exists my API. And I can't use this library that was very useful for our project. So it just made it a little bit harder and complicated.
Jetpack Compose is the Android UI toolkit that we use for our application development. And it removes the need to use XML files to create the UI views. Instead, it has its own declarative syntax, which utilizes composable functions to customize and develop the desired end state of user interfaces. And these composable functions are very customizable, so you can easily configure them for any of the design requirements of our functions. And the programming language that Jetpack Compose uses is Common, which is the programming language used for application. And it enhances the clarity in expressing these UI structures. And this led to a more straightforward, maintainable development process. As Colin was already the language you're using, you didn't have to second.
So this is just the status of our project right now as it is. So we each have different sections of it. So in the firmware side of things, we're just going to solve the errors surrounding the ability to advertise the device. So once it starts advertising, we'll be able to assemble everything together, and it'll be like putting pieces together in a puzzle. Just getting that done would fix a lot of our problems right now. Just on the software side, we were getting familiar with Android Studios and getting our grip on it. And now our current step is just to begin developing on Android Studios to stream rather than just playing back audio. So we want it in real time, someone speaking to the microphone and playing back onto the Android device. So that's what we're working on. And then also documentation, which is also very important for our project. We basically have a very hefty tutorial on ground up from this project with all the documentation that we scoured for, that we found it, and we just wrote it all down. It's a nice little tutorial we made, and we also have it on our website that we have for our project. So that's where we are with our project. And
Yeah, and then I just want to interject real quick. For the documentation, we're also going to try to hope to put a tutorial together for not just the NRF53, but also for the 52, since it's more widely used. And then when it comes to software, our current state is that we have an emulator that's able to take in audio and then play it back to you. And then for the firmware, we were able to interface with the board via a hard direct link rather than wirelessly. So we're working on just having the board be able to advertise itself and being able to accept that advertising to be able to interface with the board.
Mm-hmm. And also the reason why we're documenting is also because our project has the potential to be a legacy project, which means another group next year would be picking up our project or the year after. So it'll just give them an easier time to build up the project again. Oh, yeah.
So this is just, if you're interested in starting your own project or using anything that involves anything in our project, including Nordic Semiconductor's products, you can go to the Nordic Dev Academy, which has, I believe, 6 tutorials that are currently available where you can get certified in any of the fundamentals or use cases for Nordic Semiconductor's products. And they're coming out with more advanced tutorials. I believe last week they just published another one. And I am currently working on getting 2 certifications, one with the fundamentals, one with the Bluetooth. So as I'm moving forward with the project, I'm also moving forward in these courses. Another useful resource that Nordic Semiconductors has is the Dev Zone, where you'll be able to just go on this forum and be able to find similar questions that have probably been answered. And if there's nothing there that is specific to you, you're able to post your own question.
And for software help, one of the most important things that's helping for development was using Android developers, kind of like sort of an information dump of different libraries and examples of those libraries. So for example, they would give you the set audio attributes library, and then it would give you all the different lines of code. You have to change the positions to make sure that it's able to run. It give you all the different lines of code for it to be enabled and top of the signal permissions. And then on top of that, it would also give you examples on how to set it up, how to make a button, for example, if you're trying to make a button. And it was very helpful with that. Another very useful forum was Stack Overflow. Like I said, they deprecate a lot of the libraries. So if you go on Stack Overflow, a lot of people are having a ton of the same issues as you are, and there'll be suggestions for alternative libraries, and then you can implement that.
And then just going back into the documentation, here is a QR code, which has the same link to, if we were to share this document with you, you click on it to go view our working tutorial for the hardware. So it'll explain how to get started with the NRF53 and starting up a simple application such as Blinky, then moving forward in creating any project that interfaces with GPIO pins, and then later, finally, for Bluetooth, and then what our project is.